All right, so today we'll go over the last part of the chapter 4. This part is also important to understand the lab 5, which we are going to start today. So in this part, we'll learn about two different forms of writing the logic expression. Now, so far we know how to write the expression. We have seen expression. We know how to convert the expression. Um, and also we learned about the simplification. We learned how to write the NAND expression, NOR expression. We also know how to convert, how to find the truth table from the expression. Also, how to find the expression from the digital circuit. So today we'll talk about a special form of the expression which is called SOP. Which actually means the standard of product form. Okay. Now, you have been writing the expression for a while, but the way you actually write the expression, that is actually called SOP. You probably don't know the name of the form, but you have been using the SOP. Now, the SOP means sum of product. That means all of your expression will look like this. That look at this here. This is a product, right? Because this is a product of A prime B, right? Which is like a product, like multiplication of two different variables. And then this is another product, right? C D prime. But you are summing up all the products. That's why this is called sum of product form. In short, we call it SOP. Okay. Now there is a separate way of writing the expression. Is a different way. We'll also show you that. So if you have an expression which is given to you, but that is not into an SOP form, like that one. So for an example, look at the expression we have at the bottom. So this expression is not in SOP form. Okay. Why it is not in SOP form? Because if you see here, within the parentheses you have everything in SOP form, but there is a parenthesis and then you are multiplying the whole expression by C. But if you really want to get the SOP form, what you can do is you can actually apply the distributive law. Remember, we learned 3 different laws of expression: commutative law, associative law, and distributive law. So now you can actually apply the distributive law here to convert it to the SOP form. So it's very simple. All you have to do is just distribute C so to this both part of the expression. So if you distribute C, you will have a C here, you will have another C here, right? It's just like the traditional algebra, because in the algebra you also have the distributive law. So the idea of distributive law and applying the distributive law is pretty similar in algebra and Boolean algebra. Okay, but we still want to make sure you know this. Okay, now since we know about the SOP form, we also want to know a little bit more standard form of SOP, which is called standard SOP. So this is still an SOP form, but why it is called standard? Let me show you, and then you will understand. In the standard SOP form, what happens in every expression, in every literal, you will have to have all the variables. What is exactly that? Now, for an example, let me show you. So for an example, if you look at this expression here, this is already in SOP, right? This is SOP, right? This is sum of product. This is already in SOP form. But what is missing here, which cannot, we cannot call it a standard SOP because you don't have all the variables in every literal. Can you tell me how many variables you have in this expression? How many variables I have here? 3, right? A, B, and C. But look at the first literal. We don't have C here, right? In the second one, I have C. So that means this is actually an SOP, but not in a standard SOP, because in a standard SOP, we have to have all the variable in every literal. Okay? Because in the first one, I have C missing. And that is the reason why this is not a standard SOP. Now, how can I make it to standard SOP? Let me show you how we can make it. This is actually very simple, because all you have to do is you actually have to multiply the first term by C plus C prime. Because remember, you have, in Boolean rules, we have a rule C plus C prime equals to 1, right? And you can assume you have 1 everywhere, right? So what we do is we just multiply C plus C prime with the first term. Why we are multiplying C plus C prime? First of all, C plus C prime is 1, right? So you can assume there is a 1, and then you can multiply C plus C prime. And the reason we are multiplying C plus C prime, because the C is missing here with the first term. Now once we do that, we distribute the C. So we have another 2 literal for the first one, meaning another 2 term for the first one. And the third term is as it is, because there is no problem with the third term, because in the third term we already have all the literals, right? Now, as you can see here, now we have actually 3 terms instead of 2. But this is still the same expression. This expression will still give you the same output at the x column. Like if you draw the truth table, you will see that this expression will give you the exactly same combination of output for every, for every combination of ABC, it will give you the same output. That means it will have the same truth table, but the circuit will look different because you now have a longer expression. The circuit may be a little bit longer, but it will still be standard, giving you the same expression. That means this is still an equivalent expression, okay? So, but you might be wondering why I need to know these, because these are just the same expression, but we are just writing in different forms, right? Because we know the SOB, and then we are just trying to make it a standard SOP, and eventually we can see that standard SOPs are even longer, right? They are equivalent, but they are longer. So that means this expression, you make your circuit bigger, right? So to understand why we need this standard SOP, we have to wait until we go to the next lecture, where we will be learning about a new simplification technique. Remember, we already know the simplification using Boolean rules, right? But there is another way of doing simplification, and to do that simplification, every single expression we have to have in a standard SOP form. That's why we are learning about the standard SOP first before we learn about the technique which actually can do the simplification. Let me show you another example of how we can do the standard SOP. Now at this time we have an expression. This is an SOP for sure, but this is not a standard SOP. Why? Because we have 3 variables here, right? A, B, and C. But if you look at here, in the first term, C is missing, right? There is no C. In the second term, B is missing. So idea is still same. We'll multiply the first term by C plus C prime, right? And once we do that, we distribute it. We are done with the first term, but we're still not done with the second term, meaning right now this is the third term, because I have 2 terms for the first one. And in the very last term, I have AC, right? But I still have B missing, so it's very simple. All I have to do is just multiply this by B plus B prime. So what I do is, whatever the variable is missing, I multiply that term by B plus B prime. So once I do that, I distribute everything. Now I have 4 different terms, but this expression is still equivalent to the very original expression that we had here, because if you draw the truth table of this expression, this will still give you the same output at the column X. But the circuit looks different because this is longer, but we still need to know how to write the standard SOP so that we understand our next simplification technique, okay? We already know the simplification, but we know the simplification using Boolean rules. But there is a very important way of, another way of doing the simplification that doesn't require Boolean rules, okay? But what that requires is we have to have every expression in a standard SOP form. Any question here? Okay. Now, if we understand up to this point, we'll stop. We should be ready for our next 2 quizzes, which actually covers this only actually will cover the first 2 quizzes. I'm sorry, 21st and 22nd quizzes of chapter 4. Okay, and I'll stop here for today. so that we can finish this part of the quiz, and then we'll jump on to the next part of chapter 4, okay, where we'll talk about that new simplification technique. Now remember, no matter whether you use the simplification using Boolean rules or simplification using the new technique that we'll be learning, you will still get the same outcome because it will be still the same result, okay? It will be just two different techniques. But to understand the technique, we are just trying to see whether we can understand the standard SOP form, then we'll go from there, okay? So let me stop my presentation here.